let's dive into the tiny, unseen world that actually determines how our medicines work. It's a huge manufacturing puzzle, and the secret is totally microscopic. The difference between a perfect pill and a total failure, it's all about these tiny crystals. So here's what we're going to cover, from the basic problem to the high-tech future. Okay, let's get right into it. The secret ingredient here is the shape of the drug's crystals. Scientists have a word for this shape: morphology. And honestly, it dictates everything. See, a drug starts as individual molecules. The way they link up defines that final crystal. Get the shape right, everything flows. Get it wrong, you clog up the entire factory. You know, for years, this was all just trial and error, super slow and really expensive. But what if you could skip all that and just design the perfect crystal from the start? Well, that's exactly the goal of projects like 80 Dropped, to build better drugs digitally. Let's use a drug we all know, ibuprofen. These are its basic molecular building blocks. So the big question is, if these molecules stack together, what shape do they make? In a perfect vacuum, software predicts this neat, compact, plate-like shape. Pretty cool, right? And check this out, the digital model is a near perfect match for the real thing. But here's the catch. Real factories don't operate in a vacuum. They use special liquids or solvents. And look what a difference that makes. One solvent gives you plates, another gives you long needles. You can see it so clearly here. The solvent choice completely transforms the crystal's final shape. So who cares if it's a plate or a needle? Well, back on the factory floor, it matters a lot. Turning these raw crystals into a finished pill is a really delicate, multi-step process. And those needle shapes, they are a total nightmare. They clog filters and jam up the whole line. Basically, they can now use software to pick the crystal shape that will manufacture perfectly. This whole digital approach is a game changer. You design away problems before they even start. And the ultimate goal, it's something called a digital twin, a full virtual copy of everything. This is just the beginning of a digital revolution in how we make our medicine.